Lesson 1.1a is on solving one variable equation. So we want to solve one variable equations with one or two steps using inverse operations. Hopefully a lot of these concepts sound familiar from last year. So thinking back to last year, hopefully we talked about inverse operations. So if you think about addition, what's the inverse, in other words, opposite of addition? Well, hopefully you remember that it is subtraction. So addition and subtraction are inverse operations. And then if we think about multiplication, what's the inverse of multiplication? It is division. So those are the inverse operations we are talking about today. And then our overall goal when we are solving equations is to isolate the variable. In other words, to isolate x, to get it by itself on one side of the equation. Let's practice a couple of problems together. Make sure you are following along in your notes, writing down every step of the work. So this first problem, we have x divided by 5 equals -4. Well, we want to get x by itself, so we're going to think about what is the inverse of dividing by 5. Well, the inverse of dividing by 5 is multiplying by 5. So now I have 5 divided by 5. Well, those are just going to cancel each other out. And since I multiplied by 5 on this left-hand side, I have to multiply by 5 on the right-hand side. So we end up with x is equal to -4 times +5, which is -20. So x equals -20. And there we used our inverse operations, right? We used the fact that multiplication is the inverse of division in order to isolate x. Let's try it with this other one. So we have 5 equals x minus a -6. So this minus a -6, there's a couple of different ways you can handle this. Well, here we are subtracting, right? This is a minus sign, so let's just add it. Well, we are, instead of subtracting a -6, our job is to add a -6. So we will add a -6 to both sides. Well, these are just going to cancel out, okay? 5 plus a -6 is the same as saying 5 minus 6. Well, hopefully you know 5 minus 6 is -1. So x is -1. Another way you could do it, if you wanted to look at it, you could say, well, 5 equals x minus a -6. Well, we could multiply a negative times a negative, and that creates a positive. So we would just end up using the inverse of addition, but we would still end up with -1. So for a lot of these, there are a couple different ways to approach them. Let's look at a couple more. So we have 2x minus 11 equals 6. Well, we have a couple different operations going on. We have multiplication and we have subtraction. So when you're looking at this, you should always do addition and subtraction. You should always do the inverse of that before you do the inverse of multiplication and division. It just makes the problem a little bit easier. So the inverse of subtracting 11 is adding 11. So we're going to add 11 to both sides. Well, all we have left is 2x on this left-hand side, which is equal to 6 plus 11, which is 17. Well, now we have 2 times x equals 17. So we can do the opposite or the inverse of multiplication, which is dividing. So x equals 17 divided by 2. And you can just leave that as an improper fraction. Now would be a good time to pause and see if you can figure out this next one. So we have 15 equals 10 minus x. So here's another one where there are a couple of different strategies you can use. So I am going to start and I'm going to subtract my 10. It's a positive 10, so the opposite or the inverse would be to subtract it. So 15 minus 10 would be 5. Well, this is equal to a -x. Well, notice how -x is not the same as just regular x. So since we have a -x, it's kind of like having -1 times x. So in order to get x by itself, or to isolate x, we should divide. Well, that way these negatives are gone, and 5 divided by -1 is -5. And that is our final answer. All right. Here we have a couple different things going on. So we have 3/5 times x equals 6. So here's another one where there are a couple different things you can do. If I'm looking at 3/5, right, this fraction I could multiply by the reciprocal, or I could break it up. So let's break it up. we're dividing by 5. So if we just look at this dividing by 5, the opposite of that is to multiply by 5. So let's multiply both sides by 5. That way this is gone, so we just have 3 times x on the left-hand side, and then 6 times 5 leaves us with 30. Well, now we have 3 times x equals 30, so we can divide, which leaves x isolated. So x will be 30 divided by 3 is 10. X equals 10. All right, we have 2 more that we're going to look at. So p divided by 7 plus 3 equals negative 12. So this is another one where we have a couple different operations going on. So you do your addition, subtraction before you do your multiplication, division. So since we are adding 3, the inverse of that is to subtract 3. So we have p divided by 7 equals negative 12 minus 3 is negative 15. Well, we have p divided by 7. The opposite of dividing by 7 is multiplying. So we end up with p equals negative 15 times positive 7 is a negative 105. So that would be our final answer. Last but not least, we want to solve for the variable. So we have a lot of stuff going on here. 7 times x minus 8 divided by 5 equals negative 7. So this numerator right here, we actually want to treat that as though it's in parentheses. And the very first thing we should look at, or that we should deal with, is this dividing by 5. Well, the inverse of dividing by 5 is, hopefully you said multiplying by 5. So these are gone. So we have 7x minus 8 equals negative 7 times 5, which is negative 35. And now notice how this looks a lot like one of those regular problems. So now would be a good time to pause and see if you can finish this one off. Well, we want to do our subtraction first, so we're going to do the inverse, which is adding 8. So we end up with 7x equals a negative 15. Oops, no it does not. I'm sorry. Negative 27. All right, here we go. 7x equals negative 27. And then we are going to divide by 7 because divide is the opposite or the inverse of multiplication. So our final answer is x equals negative 27 divided by 7. And that is our final answer. So as we're looking at solving our one variable equations, your job is to isolate the variable x using those inverse operations. Using